Let's start with the MPS revisited topic. 2 weeks ago in the MPS 3.0 webinar, we talked about primitives and how you define elements, really building parts that you can use to create your building information model. I compared it to Legos. Legos have, or when you buy a box of Legos, it's a predefined set of standard components, and you can build really everything with that. And together with the staged approach, so with the guidelines that you get, you can build the project that you're working on. Now, during the preparations for this webinar, we also compared it to an IKEA project. I think that most of you attending today's webinar have completed at least one piece of furniture that you purchased at IKEA, and what we thought was very similar to how you approach or should approach a virtual construction project is that as soon as you open the box, you start to organize the pieces that are needed to build the cupboard or that piece of furniture that you bought. Everything is labeled, and you know where everything goes. So pretty similar to what we want to achieve when we work on a virtual construction project. The difference being that it's not the side panels of a cupboard, but we work with building elements. And for each of the building elements, what we need to include in the virtual construction model, in the building information model, is a design component, a cost component, and a schedule component. And those together form the building element. Those together provide the information that we need for cost and schedule planning. So what we want to do with a model progression plan, with a virtual construction plan, is to provide a toolkit for teams so that you get the pieces that you need to complete a stage or to complete stages in your virtual construction project in order to provide the input that is needed for decision making at the end of a stage. We talked about the aspects that are included in building elements, as well as the level of detail. So this table, or part of the table really, shows what aspects are. So aspects are the components that I just mentioned that need to be part of the building elements. So we need a model component, a cost component, and then further down there's a schedule component as well. And for each of these aspects, we can recognize various levels of maturity. So for a model class M0, that would be the 0 level of maturity for the model aspect. There's no model. Then an M1 class model would be a massing model. M2 would be building elements with approximate dimensions, all the way down to M6, which would be as built. Now we can do that for each of the aspects in your set of data. So for model, cost, schedule, and we mentioned as well that you could think about things like energy calculations as well, if that is an aspect that you want to include in your building information model. And then you map that to the overall target and level of detail. So the numbers that we recognize are here to the left. Those numbers could be company specific. So if you would like to increase the level of, or increase the number of level of details, you could do that. You can add a 150, for example. But the power of using aspects is that you can map the various aspects to a targeted level of detail. So you can say here that level of detail 100 requires a class M1 model, a class E2 estimate, and a class S2 schedule. That way it becomes a lot easier to communicate to all parties involved what is expected from them as a contribution to the project's building information model. Primitives simplify that task. They're pretty much examples, so the Legos that you use to define the specific content for your project. And what we're looking at right here is a primitive that's defined as a solid wall, so not a multi-component wall, a solid wall, and we've got the classes in which they that wall can occur in a project. We've got an M2, which is basic diversification by material and construction method, and M3 would be thickness and type per schedule. So that's going one level up. And M4 would be including additional properties that would be needed for estimating and scheduling purposes. So, for example, specific materials that would be needed. So looking at this, you provide guidelines for the designing parties or the people who create the model for the project. And by following these guidelines, everybody gets at the end of the stage what is needed and what is expected. So for estimating, there's the same thing that we can define: average cost per element for E3 class, cost per unique element for an E4 class, and then at an E5 class estimate, we would go down to the resources level. So from a modeling point of view, this is what that could look like. So if you have an M2 class solid wall, only the window and door openings are modeled. Basic diversification, so you work with one average or generic size for the wall, one generic thickness of the wall, and that's what you model everything with. When you go to an M3, you recognize the various thicknesses in the plan, and that means that the collection of wall elements that you need to work with is growing, still using the same primitives, so still using the same guidelines. And then in M4, you are going to recognize additional properties needed for estimating and scheduling, so assigning materials, and also you might want to include the openings for penetrations for the MEP runs that are included in the project design at that point in time. Those guidelines, so those standards, will then help you to define a stage or data set that can be used to complete the work in a stage. So what we look at right here is on the horizontal axis we got the stages in the project. Right now we've got 4, but of course you could have many stages throughout the course of the project. What we've done so far is stages every 4 weeks or every 6 weeks, depending on what you agree on with the project team. For each of those stages, before you start, you define what the goals are, and based on those goals, you define for each of the building element categories, so groups of information, what the level of detail is. The targeted level of detail then leads to a required class for each of the aspects, so a model class, a estimating class, and a schedule class. And with that information, you can build the collection of elements. So that's similar to what we saw earlier in the image with the IKEA box, the piece of furniture. Before you start building that piece of furniture, you group the pieces that you will need at a certain point during the assembly process. MPS 3.0 means working with those primitives, so describing the requirements for each of the elements, but also using a warehouse. And a warehouse is really a repository of your building elements for the model that you're going to use, for the estimate that you're going to put together, and for the scheduled tasks. Now, the 5D data pack is a warehouse for all of your projects. So I've started to talk about the MPS, to do a recap of the MPS before talking about the 5D data pack, because what you can do now is open the 5D data pack and copy elements that you need for a certain stage in your project into your stage warehouse from the 5D data pack.